Hello and welcome. In this video tutorial, we're going to take a look at the homework to Unit 7, Lesson 4 on tangents to a circle. Please remember to pause or rewind the video as necessary. Let's take a look. Question 1. In the diagram shown, BC is tangent to circle A at point C. If AB is 17 and BC is 15, which of the following is the length of radius of circle A? Well, let's fill out the information on the picture. Here's the radius to circle A. Draw that in. Perpendicular, the tangent line. Tangent line is always perpendicular to the radius. We were told that tangent line, or the hypotenuse to that tangent line is 17. We were told that BC, the tangent line itself, is 15. And we're trying to find the radius, which is AC. This would be A. This would be B, which is the unknown. This would be C. We will use Pythagorean theorem to analyze this. A squared plus B squared equals C squared. That would be 15 squared plus B squared equals 17 squared. 225 plus B squared equals 289. Subtract 225. And B squared equals 64. Square root both sides, B equals 8. Now, in our Unit 5, we learned that taking the square root of something, we need a plus or minus, right, answers, plus or minus solutions. That's not the case here because radius is a distance and distance is always positive. So we're always going to take the positive root when we do this kind of solving. And that would be option number 2. Circle O has a diameter of length 16. Okay, point C is located outside the circle such that it lies 12 units from the circle's center. What would the length of a segment drawn from C tangent to circle O be? So let's draw what this could look like. So we've got circle O. You've got a tangent line. So I'll just draw a tangent line like this. And there's a point C located outside the circle. So when we say outside the circle, you know that the radius is the distance to the edge of the circle. So outside the circle must mean something like this. So point C is just out here somewhere. Now the length of the diameter itself would be 16. We were told that it's 16. So that means the radius itself is 8. The distance is 12 units from the center. So this is 12. And we're looking for this distance here. What would the length of the segment from C tangent to the circle to O? So in other words, what would that be? Well, that, again, we're going to use Pythagorean theorem. So we'll call that side A. That's the question mark. Side B is 8, and 12 would be C. A squared plus B squared equals C squared. A squared plus 64, 8 squared is 64, equals 12 squared, 144. Subtract, and we get A squared equals 80. Now, when we take the square root of both sides, we get A equals the square root of 80, but you have to break that up, okay, and actually simplify the radical like we learned how to do in Unit 5. The largest perfect square that divides into 80 would be 6. Let's see, it would be 16, yes. So we're going to turn 80 into 16 times 5. That's the same as 16 square root of 16 times the square root of 5, which is 4 radical 5. In question 3, shown on the circle A, segment CD is tangent to the circle at point D. if CD is 23, CA is 28, what is the closest to measurement of angle C? So you can see a triangle that's formed here by the radius making the other end of the triangle, and it's a right triangle. So angle C is right here. Now, actually, to find the missing angle, what we can do, the concept that relates angles to the sides of triangle would be right triangle trigonometry. And we had a little acronym that sort of helped us remember the different trigonometry ratios. And it was SOHCAHTOA. And these helped us remember the ratios of sides of a triangle. Sine of an angle was equal to the opposite side divided by the hypotenuse. Cosine of an angle was equal to the adjacent side divided by the hypotenuse. And the tangent of the angle was equal to the opposite side divided by the adjacent side. Well, what do we have here? We have angle C. This side here is next to or adjacent to C. This side here is clearly the hypotenuse because the hypotenuse is always opposite the right angle. So what trig function would we use? We would use the one that has adjacent and hypotenuse. Adjacent over hypotenuse. Okay, so we're going to set up the following equation. Cosine of angle C equals adjacent over hypotenuse. Now, we can state that again. Cosine of angle C is 23, that's the adjacent side, over 28, that's the hypotenuse. Now, to solve for the cosine of C, what we're going to do now is we're going to take the arc cosine or the inverse cosine of both sides of the equation. So I'm just going to kind of move this over here, and I'm going to take the inverse cosine or cosine to the -1 of both sides of the equation, like that. Now, the inverse cosine cancels the cosine, so we end up with C. And the arc cosine of this ratio, 23 over 28. And if we do that, now keep in mind, your calculator does need to be in degree mode. So if you're not sure how to put it in degree mode, see me in class and I'll help you with that. But taking the inverse cosine of 23 divided by 28 gets you roughly about 34.8 or 35 degrees. Number 4. Circle O is inscribed in triangle RST such that the tangent points M and P. If RP is 7, let me kind of darken this in a little bit. RP is this one right here. So RP is 7. RT is 17. So the whole thing across would be 17. And SM is 5. Let's go ahead and make that. SM is this one right here. And that would be 5. It says, then what would the length of side ST be? So ST is this big long one down here at the bottom of the triangle. Okay, so here's what we need to find. Side ST is essentially going to be side NT, that's this side here, plus side NS, this little segment here. So we have to add up those segments. Well, one of the things that we learned was that if you have a tangent line, actually 2 tangent lines, and those 2 tangent lines intersect at the same point. So you can see this tangent line intersects at that point, this tangent line intersects at that same point. If you have 2 tangent lines that intersect at the same point, then this tangent line is equal to that one right there. Now here's what we know. The whole thing is 12 all the way across. not 12, sorry, 17. The whole thing is 17 all the way across. Okay, so what that means, of course, is that if that's 17 all the way across, then PT right here should be 10. 10 plus 7 is 17. But if this is 10, that means this is 10 also, because those two tangent lines, this one here, are essentially equal because they intersect at the same point. Using that same logic, this tangent line here is going to be equal to this one here because they both intersect at point S. And if this is 5, well, this is going to be 5 too. Therefore, segment ST is going to be equal to NT, which is 10, plus NS, which is 5, for a total of 15. Question 5 says, in the diagram of circle K, tangents are drawn from point A to points B and C on the circle. If the measure of arc BC is 96 degrees, then what is the measure of angle A? Show how you arrived at your angle. Let's label this on the page. So I'm going to make this gray arc right here, BC. That gray arc is going to be 96 degrees. Now, something you should know, you have a central angle here that's intercepting the exact same arc. Therefore, that central angle is a direct measurement of the arc, and that central angle is also 96 degrees. Something to keep in mind there. Now, what we're looking at here, we have to be able to figure out this angle. Now, this angle can be figured out if we know the remaining part. And so here's what we're going to have to do. Let's find some of the missing angles here and there to sort of help us out. We have to find this angle A here. But notice this triangle, this blue triangle right here. Well, one thing I know is that those two tangent lines are intersecting at the same point. So I know that AB is equal to AC. I know those are congruent. AB is congruent to AC because those two tangent lines are congruent to each other because they intersect at the same spot. Well, that's helpful because that creates what's called an isosceles triangle. That means this angle here is also the same as that one there. So once we find one of those two angles, we'll know what two of those angles are, and then 180 minus those two angles would give you the missing third angle. So that's sort of the strategy that we can use to kind of figure this out. But what would be helpful, of course, is to figure out this missing angle here and this one here. Notice we have another isosceles triangle here and here. BK and CK are both radii, therefore they are the same. Those sides are the same, which means, ladies and gentlemen, that these angles here will be the same. So here's how we're going to set this up. We're going to figure out what those blue missing angles are. And to do that, we're going to let angle CBK and angle BCK equal X. So we're going to let this equal X and we're going to let that equal X. We're going to let both those blue angles equal X. Now, since they're the same thing, here's what we know. We know that X plus X, we know that this angle plus this angle plus this angle has to add up to 180 degrees. So X plus 96 equals 180. Well, that's 2X plus 96 equals 180. At this point, let's remove the 96. And we get 2x is equal to 180 minus 96 is about 84. Go ahead and take half of that, and x, the blue angles, each blue angle is 42 degrees. So this is 42 degrees right here. This is 42 degrees right here. Now, something you should be aware of, this entire angle here is 90 degrees, because remember, this is a radius, this is a tangent, and they are perpendicular to each other. So this angle here, right here, is just going to be 90 degrees minus 42. So let's figure that out. This angle right here, and the same angle right here will both be 90 degrees minus 42, which is 48. So this is 48. That's 48. So here we go. Now we're going to take a look at only this blue triangle right here. And we can do that by saying 48 plus 48 plus x, we can call, or not x, we can call it angle A, is equal to 180 degrees. Three angles have to add up to 180. So 48 plus 48 would be 96. So add those together. 96 plus A is 180. Let's go ahead and subtract the 96. And angle A is about 84 degrees. A lot of angle relationships we had to look at in that one. But good work with isosceles triangles as well. Question 6, in the diagram shown, triangle ABC is isosceles with AB equaling CB. So AB equals CB. And you should be able to tell that because there are two tangent lines intersecting at the same point. So you should have known they were the same without them actually saying this statement here. Circle M is inscribed in triangle ABC such that it is tangent at points D, E, and F. The length of BF, okay, so let me color code this. The length of BF right here, the blue line, is twice the length of CF, the gray line. And the perimeter is 32 inches. Determine the side of BC in inches. Okay, here we go. So what we're going to do is we know that side AE, AD, DC, and CF all equal the same thing. Okay, why is that? Okay, so these two radii right here, and then these two radii right here. So this distance are the same. All those distances are the same. This tangent line and this tangent line, they're meeting and intersecting at point A. Therefore, AE and AD are equal. This tangent line and this tangent line are meeting at point C. Therefore, CD and CF are equal. Since they come from the same radii, then all four of those segments, these, this one, and this one, are all equal. So that's what we're going to start off by saying. We know that AE is equal to AD is equal to CD is equal to CF. Okay, we know all that. And we know that BF is equal to BE. Those ones are also equal. They're longer, but those two are equal to each other. BF is equal to BE. Now, here's another thing we know. This segment plus 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 this segment has to add up to 32 because that would be the perimeter. So what I will do is I will call each of these smaller segments, let these equal x, and BF and BE are twice as long, so they're going to be 2x and 2x. So here's what the equation would look like. X, which stands for AE, plus X, which stands for AD, plus X, which stand for CD and CF, plus 2x plus 2x, which stand for BF and BE. Now, if you add them up, those are 6 total segments. 1, 2, 3, 4, 5, 6 total segments that have to add up to 32 inches. Well, adding this up, we get 4x right here, plus 4x right here is, of course, a total of 8x, and that's equal to 32. Add the 8, or we divide the 8, excuse me, x equals 4. So we have x equals 4, which now if you look at BC, BC is this entire length right here. So if x is 4 and BF is twice that, or 2x, that would be 2 times 4, this would be 8. So BC, side BC, is side FC plus BF. So it would be 4 plus 2 times 4, or a total of 12 inches. In number 7, circle M, segment AB is tangent to the circle at point C. AB has endpoints such that AM is perpendicular to BM. AC is 9, BC is 4. What is the length of the radius in circle M? Show how you arrived at your answer. What we're going to do, ladies and gentlemen, is we're going to use similar triangles to make this work. And here's how we can do this. There are 2 triangles here. There's the black triangle, and there's the blue one. Now they both share the same right angle here. And side CM is the same length for both sides. It is shared leg for both sides. Okay, now it's going to be a proportional leg. You'll see what I mean in a second. So what I'm going to do is I'm going to take each of these and drag them out, and you'll see how we can use similar triangles. So this right here, I'm going to trace this, and I'm going to pull this out. That becomes triangle ACM, just like that. Well, then what I'm going to do is I'm going to trace out the other one. This one right here. Let me pull it out. And if you notice, and I rotate it, they're kind of the same, huh? This side right here came from the top, so that's M. This side came from here, that's B. And this side, of course, is C. So we can set up a proportion. This leg is related to that leg, so AC is to MC, and that's proportional to, we could go MC to BC, the side of the leg. MC is to BC. And essentially what you'll do is you'll go ahead and do your cross products. So we get AC. Actually, let's go ahead and throw in some numbers here, just make it easy. AC, we saw, was 9. So this is 9 over MC. Do we know what MC is? Let me see. So we know AC is 9. AC is 9. We know that BC is 4. Okay, we know BC is 4. And that's all we know at this point. Yeah, that's all we know. Okay, so I'm going to call side missing MC, I'm going to call that just X. So 9 is to X as X is to 4. And again, if I take my cross products, what I get is I get X times X, or X squared, equals 9 times 4, or 36. Square root both sides. Do not worry about plus or minus because you can't have a negative distance. And X equals 6. I hope you found this video tutorial helpful. Again, please pause and rewind as necessary, and thank you.